Human in the loop from a planning, an architecture, a design standpoint, human in the loop with respect to verification of the actual PRs before they were merged and turned into production. And then the mechanics of the work, the stuff that was so important for most of our careers was automated.
Hello, and welcome, folks, to another episode of HangarDX podcast. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. On top of everyone's mind today, these days, it's AI, so that's what we also cover a lot. I'm your host, Ankit, co-founder of Aviator. At Aviator, we are building frameworks for building guardrails for AI coding platforms. And today, my guest is Wayne Duso, joining in from 1Password. He's leading a lot of AI transformation at 1Password, so we will be diving into that. But before we get started, Wayne, thank you so much for taking time out of your busy life. We'd love for you to just introduce yourself for our audience.
It's a pleasure to be here with you. So my name is Wayne Duso, and I am a senior engineering leader at 1Password. My official title is Vice President of Platform and Infrastructure. My preferred title is Builder.
Amazing. Do you want to also touch up a bit on your background as well? I see you've spent over a decade at Amazon. So just bring us to kind of brought you to 1Password today.
Yes, so I spent all my life as I like to refer to myself as a plumber. So I've spent my entire career, my background is in computer science and systems engineering. And so I've spent my entire career building infrastructure, whether it's compute infrastructure or network infrastructure, or storage infrastructure, which is what was doing at AWS mostly. I've spent my entire career building the infrastructure, services and products that, whether it was the internet or developers, a lot of what their work is built on and shipped on and operated on is what I've been building my entire career. So here at 1Password, I have a very similar role, and that is how do we continue to build and scale our platforms and our infrastructure so that we can continue to support the enterprise customers and the individuals that are customers day in and day out.
Amazing. I feel like every organization, software organization today, there is a lot of focus on platform engineering. And largely because we are going through a big movement, I feel like, in software engineering. So give us a bit of picture of how does 1Password software engineering looks today? What does a team structure look like? How big is a platform team versus sort of the product team, and are there other functions?
Yeah. So today, the way that we're structured is we have a product engineering team and a platform engineering team. And both of those teams are consist of product management and engineering. So it's a very familiar model for a lot of folks. If anybody who's familiar with how AWS worked for many years, we see them as the product folks responsible for one outcome for our customers, which is, are we in fact providing customers with the right solutions, the right products, the right platforms that they can use to do their work, so that they can make sure that they're running in a secure, private, and trusted environment.
Given that we're going to talk about AI adoption, I would love to first understand from your perspective, for an organization which is very security focused, how do you folks think about AI adoption and challenges with it?
Yeah. So we are at the beginning of our journey for AI adoption. We started this journey in Q4 of last year. So, like a lot of folks, have we figured everything out yet? No, we haven't. But not with respect to our core priorities, which is, 1Password is a company that is responsible for the privacy and security of millions of customers, hundreds of thousands of enterprises, with respect to their credentials, their secrets, how they're used, when they're used, and so we really do focus on everything we do to make sure that we never think about our work in terms of simply going faster or using the latest technology, but how do we leverage the shift in where we're headed. Like, engineering is shifting in terms of how we do engineering, how we perform engineering. How do we leverage those tools while not giving up on any of our core ethos and principles? And that is privacy and security for our customers, to ensure that their digital lives and the digital lives of their agents are always at the front of our minds. And we have a number of ways that we do that today using the new tools.
So let's dive into this a little bit more. So you mentioned that the flow of engineering work has changed. Can you describe a little bit more about like how does that look like today?
Yeah. So when we introduced, like most companies, we introduced agentic workflows first in the building, phase of
Hmm.
the CI for coding by and large, and then for coding and test generation. And for the first quarter, that was fine. People got used to the tools. They started to trust the tools. You have the typical 20-60-20 split with humans. You got the leading 20% that they love new tools, they love new shiny objects, so away they go. And you have sort of the middle of the population, which they're very focused on their work, and when you introduce new change or change into their world, they're going to ask questions like, "Hey, I'm kind of busy right now. Do I really need to do this?" And then you have the 20% on the other side, which is, I've seen change happen before. It doesn't go well. And so that's just a reality that we have to deal with in no matter what we do as leaders. So when we introduced coding capability,
Hmm.
we needed to make sure that folks trusted the process. And it wasn't about just generating code. It was really, what do these tools do to allow us to be better engineers, to think about engineering in a way which is more productive. And then we needed to define what more productive looked like. So initially it was a conversation. We introduced the tools. The front 20% will adopt these tools. How do we learn from that top 20%? How do we take what they're doing and have that adopted by that middle 60%? And even the trailing 20, how do we start bringing those folks along so that they understand this is not about simply AI. It's about the evolution of our engineering discipline.
Very interesting. So you said that you're seeing sort of like, the org's bottleneck now is shifting from building to planning. Do you want to maybe kind of like expand on that a little bit? Like how is that playing out in the SDLC today?
Yeah, I think this is probably one of the most fun areas, and for the following reason. If you think about how engineering is generally done, you have a few engineers that are amazing at sort of we'll call it the system design architecture piece. Like, they start on the left-hand side of the whiteboard and they work all the way to the right-hand side of the whiteboard in an amazing fashion, right? There's not a lot of those folks out there, but they do, right? Um, if you think about the majority of engineers, like, they kind of start in the middle of the whiteboard and they start, drawing, right? And eventually you start asking questions, and sometimes they move to the right, sometimes they move to the left. It depends on the question. Okay, that's at human speed. What happens when you're working at AI speed or agentic speed? Like, if you just jump into the middle of a problem with what essentially are a set of agents that are really enthusiastic about meeting your needs, um, you probably are not going to end up on either the left hand or right hand side where you expected, but you're going to end up with something else. And we found this to be incredibly true with one of our first, we'll call at scale experiments. So yeah, I can go through that if you want to go through an
Yeah,
example.
let's do it.
I think this. So we wrote a paper about this, and it's going to tie a few things together. So
Okay.
we wrote a little blog about this, and
Hmm.
we can give you a reference after this, where we talked about one of the tasks that I'm directly responsible for, which is to refactor our monolith into a set of we call it purpose-built services. I won't use the word microservices; it's not quite that, but it's domain-specific services. And in
Okay.
our world, we're a security company, we're an identity company, so identity services, authorization services, and we call it our vault service, our credential vaulting service. And so, you know, a lot of folks got really enthusiastic. The front 20 got really enthusiastic because of things you could read from other companies saying, take your entire code base, give it some basic prompting and let it rewrite your entire world. Well, we're a security and privacy company. That's not going to happen, right? So when we sat down and we looked at running a 6-week proof of value, POV, on how we can use these tools to perform refactoring, would it help us refactor better? Would it help us
Hmm.
refactor faster? We discovered that, um, like most, it's not going to work out really well by simply giving it simple instructions. So we stepped back. We said, well, what would the best engineers do? And by best, I mean, what would the most sort of system thinking engineers do in terms of taking this problem and breaking it into its constituent pieces, and then assigning those constituent pieces to various individuals, in this case, various agents. So one of our engineers sat back and tried to do the easy experiment first, and realized the models, within the context that the models could understand, it quickly fell apart. So that person stepped back and said, what we need is deterministic understanding of our code base, not probabilistic understanding of our code base. So they used the tooling initially to build tooling, to build deterministic tooling. So they ended up building an abstract syntax tool,
Tree. Hmm.
go through our entire code base in a very deterministic way. But they were able to generate that tool in a matter of hours. The end result was an amazing spec of our entire system. Something which, frankly, if you sat, some really good engineers at it for a month or so, they would probably come up with the same thing, plus or minus something. So we ended up with an incredible schematic of our current system. We understood the relationships between all of our current services, all of our current over 900 endpoints, and those relationships to our data sources. That gave us the ability to say, we understand how to refactor our code base, and we understand that these tools have the ability to facilitate our doing that. We ran one of the first experiments against what the domains now look like. And we ran that experiment by brainstorming with, we were using Cursor at the time,
Hmm.
brainstorming with Cursor to understand, what our plans could be, what the architecture should be, refining that with human oversight. And within about 7 days, got to a place where we had an incredibly well-written spec in the epic that was responsible for this. We can talk a little bit about how we use AI and epics and specs in a minute. And it ended up creating a spec along with the principal engineer that resulted in 17 agents that would be required to refactor this one component of our monolith to produce the system architecture that we believe was correct and appropriate for the work that we do from a privacy, security, and resiliency standpoint. So we did all of that work up front, which is a lot of, if you would, planning, but planning's too easy a word. It's really brainstorming, right? It's really design. It's really architecture and doing that work. And then when it was executed, it took 4 hours. And that was it. It was 4 hours worth of work. The PRs were posted. We could then go and look at the 17 set of changes and then the small changes within those and actually start approving those PRs with human in the loop. So human in the loop from a planning and architecture, a design standpoint, human in the loop with respect to verification of the actual PRs before they were merged and turned into production. And then the mechanics of the work, the stuff that was so important for most of our careers was automated. And and that's why we wrote the paper, because we wanted people to understand, there's a way of applying these tools to get to a better result, to get to a superior result, frankly. But you need to do it in such a way that it was in the context of engineering. They're not magic.
Wow, that's amazing. So, for what it's worth, I think this is also something we have seen or like talk about in some of our sessions around that AI is an amplifier. If you don't have better tools, if you don't have better practices, it is going to amplify also a lot of garbage. And the organizations who are seeing significant value are the ones who are investing time into better processes and better tools. So I would love to kind of like maybe just pick a few pieces from there. So you obviously talked about how you did brainstorming and planning with it, and then sort of the verification and the review side of things. Let's just talk about brainstorming part. So you mentioned you kind of like created this whole AST to actually like be able to define entity relationships, service relationships. How did you feed that to the agent? Is it like so you give a list of documents, agent crawl through those? Are there sort of like RAG systems? Like, did you kind of like build some tooling around that?
Yeah, it was actually fairly straightforward in this particular exercise. So I don't want to extrapolate into what theoretically could happen. I'll just talk about what actually happened. So when we realized within the first week of this 6-week POV that applying the tools blindly, if you would, or with great faith, you weren't going to get the results you wanted to. So on week 2, we stepped back and said, well, how would we use these tools? And it became really clear that generating a deterministic tool using a non-deterministic model, we could verify that the tool was what we want it to be. So even at the very beginning, we generated the tool quickly. We were able to then look at what was generated, say, yes, this is the right tool. And then we're able to unleash that tool onto our code base, onto our repos. That ended up generating essentially an incredible set of MDs. So we're able to go in and actually break down, and this is part of the instruction we gave the agent as it was applying the tooling, to actually produce the right structure of markdown file that would allow us to hierarchically look at the markdown files where the top one was an orchestrator. This became this top markdown file became the description in the epics that
Interesting.
we're actually applying. So what we ended up doing is having a number of epics with a number of these MD files with a top level initiative that we pointed the agents at, pointed cursor at essentially at that point, and said, here's the top level initiative. Here's the relationship between this initiative and these epics. And then within the epics, here is the instructions you will have, the guardrails you will have to make sure that you will execute within our understanding of what is correct. And anytime that you step outside that, you will stop and you will ask us to join in as a human and making sure we have human in the loop even on the generation phase. It turned out that we ended up having these 17 agents that executed against the production of the new code. And only 2 of them needed to stop and say, we don't have enough here. We don't have enough specification. We don't have enough direction. And we've discovered that we're stepping outside the bounds. We're able to go into those 2 epics, modify the instructions, give it a little bit more direction, and then they were able to execute straight away. So this sounds like system software engineering, doesn't it? It doesn't
Absolutely.
sounds no different that you would something you would have done 10 years ago as an engineering manager or as a principal engineer by assembling 5, additional engineers or 10 additional engineers into a room and starting the process of doing a breakdown of the
Right.
problem and then what should the architecture look like and how that architecture is going to meet the end requirements for the solution. It is the exact same process, but now it can be done by a single engineer by writing or working with the tooling to generate these specs and then having the agents, if you would, the room full of engineers, execute against these specs, where every once in a while, one of the engineers comes back to the principal, to the engineering manager and says, hey, I know I was supposed to be doing X. I'm not there. Can you help me out? So
Interesting.
we're applying time-tested approaches to how you manage teams and how you manage projects. And we're applying that systems level thinking to the specs we write, to the epics we produce, and to the agents we give agency to actually produce the code.
That's amazing. In a way, this is also very profound, right? Like, we as humans are great at providing those judgment and decisions, which is kind of like in some ways forms the organizations in software engineering as a discipline. So what you're saying is essentially anytime when agents have to make those decisions, they stop and ask the humans. It's kind of like somewhat similar to Sure, like even today when we work with Cursor and Cloud Code or Codex in your terminal, you're kind of like they're stopping occasionally to ask for those questions. So you're saying is essentially during the planning phase, this is what like agents were also doing.
It's exactly what agents are doing. So during the planning phase, but even in most importantly, of course, it's the mechanics of building phase, right? Of generating the code, testing the code, and getting ready to post the PRs. This is where it really comes into play, where having the right guardrails and having the right constraints. And this is important for us as a security company because there are parts of our repository that we put a tremendous amount of constraints because we know this is where our crypto stuff is. This is where our core assets are in terms of how we ensure the privacy and the security of our customers' secrets and data. So around those parts of the repository, we're a lot more cautious. And the amount of humans in the loop from a planning standpoint, from a test verification standpoint, from a code inspection standpoint, a code review standpoint, humans are deeply in the loop on those, and our agents in those areas are actually instructed that what they can do is incredibly limited. And this is where we have a lot more humans in the loop. There's a lot of other parts of our stack, just like everyone else's stack, where it's not about trust, it's not about privacy, it's not about security, it's about functionality. And there, you can relax how many humans you have in the loop, but we still like humans to be in the loop during the brainstorming, planning, and system architecture, if you would, system design elements of this, and also in the verification steps to make sure before anything sees production, it's got a human check off.
Amazing. So maybe just one more question on brainstorming part. So you talked about like, how one principal engineer or like engineering manager sort of like can go and create these specifications working with the agent, clarifying the details. Does it also involve any kind of like collaboration or review with other humans? Or typically do you think these sort of projects are now handled solo by sort of like the senior engineers?
Like any good answer from an engineering person, it depends. And it depends on a few things. What I love about what we're doing for how we produce the markdowns, how those markdowns become the descriptions of the initiatives, the epics, and the stories as well, is that any human can go in and read these markdowns.
Mhm.
Any human can figure out, hey, do I agree with the approach or can I learn from this approach? And there's a great, by the way, the learning exercise here is just fantastic. Um,
Right.
I couldn't be more excited about this era, by the way. I've been through a few inflection points in this industry, but we are actually getting to a point where the discipline of engineering is getting stronger. And it's counterintuitive because there's a lot of narratives out there around we don't need engineers anymore. We'll just have agents. We'll just automate everything away. And the reality is that the discipline of engineering, of software engineering, of systems engineering, is actually coming to the fore because it's necessary in order to build these specifications to work with these agents so they can actually do what we need them to do without stepping too far to the left or too far to the right in what they produce. So what we're finding is that what we produce for agents and what we produce in these specifications are good for humans and agents. So we're building a collaborative exercise between the
Mhm.
human and the agents by making sure things are well spec'd. So I'm going to keep coming back to if what you're producing is strong specification for what the input is and what the intended output is. So again, intent and
Mhm.
understanding that intent and making sure that's well specified, you end up with a very strong.
Very cool. And are these specifications that you're describing, they live for the period of the task itself, or are these some things which are like checked into the code which are always true? Like, for instance, if obviously like software evolves, right? So that means the documents, like typically happens, right? Internal documents also, they drift from what the implementation is. So if we have these specifications, I don't know whether they're lasted or not, but if they are, you kind of like need to somehow maintain them as well. So give us a little bit of thought process of what's your strategy around managing specifications.
Yeah, can we go into the future for a minute?
Let's do it.
Okay. I wish I had 96 hours a day. I can't manage. I can't manage to find 24 sometimes. Systems will evolve. The Gits of the world will evolve such that a lot of the context and intent that goes into any check-in will be much richer. And I know there are folks working on these tools, but that's a conversation for a different day. Where what you use to specify, what you use to prompt, if you would, the context around any change will be captured alongside the change itself. Once we have that, I will be a happy, happy person. However, before then, we can still find ways to do this. So I've said a couple times so far, like the specifications, the markdown files that actually say what it is we're doing, the what, the why, the how, and the so what. There's actually sometimes the what's next as well, depending on what we're doing. Those are all captured in our particular case, they're captured in Jira.
Okay.
So for any ticket, and I don't like to use the word ticket because it's not really a ticket, but for any, story, for any epic, for any initiative, those are now being well documented. And in fact, as
Okay.
an engineering leader, that is my primary source of understanding, my primary source of auditing, of learning, to staying close to the work, because it doesn't just keep you close to the technical work, it keeps you close to how the work is being done. It's very holistic. It's actually so much fun. It makes for a much richer conversation. So once you carry that ticket into the check-in, once that
Mhm.
metadata has been added to, the long,
Code change. Mhm.
yeah, the long-standing code change, you now have a tether. You now have a connection back to the original intent. And again, it would be nice if that was brought into the change management system and into source control. It will happen. So
Amazing. So let's dive a little bit into the review part, right? So you kind of like talked about once a code is generated, which took only 4 hours. Talk a little bit about how long did the process of review take? So you said there were 13 changes, 17 changes?
17 agents,
17
um,
agents.
17 agents, and then many changes.
Okay, so how long did that process take? And I think more importantly, were there any surprises?
So, we started off by my saying, we're at the beginning of our journey and we haven't figured it all out. And we're not paranoid about that. Sometimes people want to be paranoid about that. And one of my jobs as a leader is to have people relax for a minute and say, you're doing great. Could we do better? Could we go faster? Sure. We can always do better. We can always go faster. But that's not really the point. The point is, do we have the confidence? Are we excited about the work? Has the work become more interesting as a function of these tools, or has it become more daunting? PR review became more daunting. It became more daunting. And so given that we're 2.5 quarters into our journey, you can't have this become the reason why the 60 or the back 20 say, see, we shouldn't have done this. So part of and we can talk about how I've structured the organization a tiny bit differently than we did before. Part of this is seeing these problems up front, and we have we'll call them a tiger team, but we have a dedicated team
Hmm.
of developers and leaders who look at these problems and say, okay, like, we know the bulk of PRs are coming too fast. How are we going to improve this process? How are we going to make sure that, yeah, we can generate code really quickly, but if we can't have quality reviews of our code and get those changes into production in a quality fashion, then we haven't really helped ourselves at all. So we had to start looking at the size of PRs. We had to start looking at um, the process of how many people needed to approve a PR. And again, as a security company, we're very specific around how we approve every PR before it goes into production, from a security standpoint, from a resiliency standpoint, and even from a functional standpoint. And so, how do we maintain that level of security and trust,
Hmm.
but not let the PR process slow us down? So we had to invent, and we're still doing this, ways of queuing up these PRs, thinning down the set of folks that need to review, but not in terms of the quality of review, but in terms of the focus, so that the people who are doing each code review are very aware of the code area and can quickly look at what the agentic, reviewing tools or code reviewing tools are telling us, and know very quickly whether it's correct or incorrect. And we actually have an adversarial set of agents at our code on our code reviews. So it's not just one agent producing the results. It's a set of agents and a very specific workflow, from very simple linting all the way through very adversarial thoughts on whether this is the right way of implementing a particular change. So using AI, using agents to do a lot of the heavy lifting of a code review, but keeping those changes relatively small, so that when a human pokes in for the final review, it becomes a much faster process in the order of the hour versus the day.
Amazing. Wow.
It's not.
So,
We're still working on it. It's still a work in progress, but that's the direction. That's the direction we're headed in.
I mean, this is also amazingly fast. Like if you said that this is like 2 quarters of work, not even, right? So, what does adoption look like then today in engineering?
So we're. I would say that I'm actually I'm shocked at how well it's going. So we started a couple quarters ago, as I said. We're
Hmm.
now at. I'm going to try to recall the metrics from memory. We're at about in 85 to 86% week over week adoption of developers using the tool set, not just a single tool, but the tool set that we've provided thus far for the CI
Wow.
process. It's been fantastic. We have a goal by end of year that will be at like 96%. And some people will say, why isn't it 100%? Well, when you're doing week over week averages, people go on vacations, things happen. So we think that 96 is probably the right answer. And in terms of code commit, right now we've gone from 0 when we started this process to 85% of our code commit is um, either assisted, augmented, or native through AI tooling, and
Wow.
it depends on the developer. Some developers are still in the assisted phase, but the vast majority of our developers are in the augmented phase, where they are using the tooling, they're using the agentic capabilities as a first order thought. Right? They're
Amazing.
really using it as a partner and not as a code completion exercise. Now we have a few developers that are really becoming AI native, and they are that leading 20%. And we have an entire structure around community that we've built, so that what they're doing is very visible to all of our folks through repositories, through Slack channels, and through monthly demos of what's possible.
Very amazing. So, when you say there is like, some developers who are AI native, how is their workflow different than sort of like your uh, middle to your adoption?
So I'll start off by saying every single time I see it, I know it. It's one of those things is like when you see the progress being made by certain developers, you get turned on to their repo, you start going back and you're looking at how they're structuring Jira. I smile. Like it's worth my Saturday night to sit down and just read their work. And so what are we seeing that's different for AI native? When they sit down every day, they don't think of their tools as, augmenting their process. They see their tools as being their coworker, right? They sit down and they think through their tools. They brainstorm through their tools. They will unleash the tools on a repository of ideas and say, this is what I'm looking to accomplish. This is the problem I'm facing. This is the what, and this is the why. Let's think about it. Is this then, you and I walking years ago into the cube next to us with our coffee in the morning and saying, hey, I have an idea. What do you think? We would do that easily. But, a lot of us are working from home or we have, remote first cultures, which work wonderfully, but only if we have this level of interaction and communication with others. The other is something now is not just, the folks on Slack or the folks they can do a huddle with, but it's also their tooling. And
Yep.
so when I see engineers who are using the tooling in a AI native way, this is what I see.
Right. And like the best part about all of this is, agents are much faster in responding back than humans can be.
They're all in, and depending on how you set them up, they can be really nice. They're really
Okay,
kind.
so I know we're coming close to time, so I have a few more questions. Maybe we can move faster on this ones. So first is understanding the impact of AI adoption, sort of like, broadly, even 1 year ago, we were still talking about like, productivity metrics. I feel like many of those things now feel somewhat dated. What is your stance on sort of like measuring productivity, understanding impact?
Well, over the every quarter we revisit our metrics to figure out if we're measuring the right stuff. We've evolved our metrics 3 times in 2.5 quarters, and every single time we do so, we look at the metric and we're like, it's not interesting anymore. So, what were the original metrics? Adoption, percentage of adoption, and now we're at the 85, 86% level. They're less interesting. Like they don't move that fast, and they don't really tell you anything. Then you go to percentage of code contributed by AI or AI augmented or AI assisted. That was interesting as well, but it's now starting. It will come at the end of the second quarter, becomes less interesting. But how did we start this? When we started, it was going to be about velocity. But we couldn't figure out exactly how to measure velocity. It wasn't clear to us. So these early metrics were fine. But now that we're in we'll call it the beginning of the third quarter, we're getting back to where we started, which is what are we really trying to accomplish? And what we're trying to accomplish is increasing the velocity of business and customer results with the same level or better quality. So what does that mean to us? Right now, we're looking at 3 basic measures from first check-in to posting a PR, from posting a PR to the merge and the deployment. And then from the deployment, we now understand what PRs had, percentage contribution by agentic workflows. Which of our deployments are flawed that have an issue? And can we trace that back to humans or can we trace that back to agentic code generation or testing or so on and so forth? So those are the 3 places looking at. How quickly do we get from first check into PR? How quickly do we get from PR to merge and ready to deploy? And once deployed, how many of those deployments are solid?
Amazing. I mean, the funny thing is, like, a lot of these things still sound similar to the Dora metrics. So, like, the beauty of all of this is, like, the more the things change, the more they remain the same too.
That is the theme. That is absolutely the theme of everything I've said today. Like what made a great engineer, 20 years ago is not different today. Their tools have changed. The analogy I'll often draw with people is like, if you go back far enough, civil engineers and mechanical engineers, when they graduated from college, if what they were looking for is their drafting board and a set of Pentel pencils, right? Like that, they've made it. Like they're able to draw professionally. Yeah, we come to this day, like no civil engineer and no mechanical engineer thinks about the drawing aspect as being successful, right? They think about the ideation. They think about, the hard problems they're solving. We've thought for so long that writing code was what made us an engineer. In fact, when we went to go hire people, we put them through coding tests, right? That was a primary way of evaluating engineers. That's no longer going to be true. The deep systems engineering, deep architectural work, the insights, the taste, right? The judgment, understanding what a proper architecture looks like. Because once that gets deployed, even though it's been mechanically generated by agents, what's going to happen when it's in production. You still have to be responsible for the architecture, for the code, for everything that's there. So it's all changing, it's all improving, and it's all coming back to the basics.
Amazing. All right. So maybe last question. What's next? What are you looking forward to in the next quarter or two? Where are sort of some of the AI bottlenecks appearing?
One of the initiatives I have going on in the organization right now. So I mentioned earlier in this talk that we did take a set of developers who really were just gung ho about what possibilities existed with agentic workflows, and we put them together in a Tiger team that works on various parts of the CI process. And one of the work streams we have for that team is from Jira ticket to PR, fully automated. And you think about it, we've been doing this for 2.5 quarters. Like, that's pretty aggressive. But if you don't try, you won't know. And in fact, the success of that process will be uncovering what we don't know. Right?
Hmm.
I consider failure to be the beginning of success, not the end. Right? And if people aren't failing along the line, along the path of this process, they're not trying hard enough. Right? We actually successfully performed this on our front end components, and so from Jira ticket to PR, using our front end libraries and all of the work that we have going on in this space, we were able to successfully take tickets that were scoped to a certain size and change, and with the specifications I mentioned earlier about within epics and stories, and have them be picked up by an agent. Um, Usually brought a human into the loop asking, "This looks like something I could do. Do you agree?" If the answer was yes, it would produce the results all the way to the PR. The PR was again reviewed using this adversarial model I talked about, and then the human got in the loop and said, "Looks great, doesn't look great," and either redid it or deployed. So this is what we need to see happen as we enter the second half of the year, and we are readying all of this for production level use, i.e., at scale for our engineers in half two.
Wow. That's amazing. I'm so looking forward to that as well. Like maybe we'll do another session in 6 months, see where things are.
I will come
So,
back with all of our failures and how we're using those to get the success.
I mean, we learn most from the failures, right? So amazing. Wayne, this was amazing conversation. I learned so much, and thank you so much for providing all the details through the process, all the challenges that you faced as well. And folks who are listening, thank you so much for listening. If you're interested in developer experience or work in platform engineering, join us at HangarDX community. It's dx.community. We also hold monthly virtual sessions and bring in guests like Wayne to provide great advice. Wayne, it was a pleasure talking to you.
Absolute pleasure. Thank you.